everyone! Welcome to TechNow Explained, where we discuss how AI and technology can affect our future. Today, we're diving into a concept that sounds like science fiction, but is rapidly becoming science fact: mind control tech. Yes, we're talking about using brainwaves to operate devices, navigate digital spaces, and even communicate. Let's explore how this invisible interface could soon become part of our daily lives. Imagine switching on your TV, sending a text, or flying a drone just by thinking. No remote, no voice commands, just brainwaves. Sounds wild, right? Well, researchers and tech companies are making this happen, and the results are pretty astonishing. What are brain-controlled devices? Brain-controlled devices are tools operated through what's called a brain-computer interface, or BCI. These systems read signals from your brain and translate them into commands that a computer can understand. Your brain naturally produces electrical signals when you think, move, or imagine. BCIs capture these signals, especially using methods like EEG, electroencephalography, and decode them using artificial intelligence. This means your thoughts can become input methods like a mouse or touchscreen. But instead of your fingers doing the work, your neurons do. Let's talk about what's happening right now. Synchron, a US-based company, has developed a device called the Stentrode. It's a tiny implant that sits inside a blood vessel in the brain and allows users with paralysis to operate computers and smart home devices using only their thoughts. No need for open brain surgery, it's implanted through the neck. Meta, formerly Facebook, is developing non-invasive BCIs. Their research team recently demonstrated decoding words and phrases from brain activity using machine learning and magnetoencephalography. Though it's not yet real-time or fully accurate, it's a promising step toward thought-based communication. Neuralink has created consumer headphones that include EEG sensors. These can track your mental focus and, in the near future, will allow you to control software with your mind during work or gaming sessions. Even the military is exploring BCIs for battlefield communication and drone control. DARPA and other agencies are funding projects to create neural command centers for soldiers. Think of your brain as a city with different neighborhoods. One area lights up when you move your hand, another when you imagine a word. BCIs use sensors to listen to these electric signals, which can be amplified, filtered, and interpreted by software. For example, if you imagine moving your right arm, the signal in your motor cortex changes. A trained BCI can recognize this specific pattern and convert it into a command like moving a cursor or selecting an app. It's like learning a new language between your brain and your devices. Here are some of the pros and cons of using such advanced technologies. Pros: accessibility. For people with paralysis or neurological disorders, BCIs provide a way to interact with the world again, sending messages, browsing the internet, or even regaining mobility through neuro-controlled prosthetics. Convenience. Brainwave tech could replace keyboards, remotes, and even voice commands. It can offer faster, more intuitive control in gaming, productivity, or smart home environments. Health monitoring. Devices that monitor brainwaves can alert users to stress, fatigue, or signs of mental illness. This could revolutionize mental health care and performance enhancement. Cons. Privacy risks. Your thoughts are the most private part of you. Capturing brain data opens up major ethical issues. Could employers or corporations monitor your focus? Could hackers steal or manipulate your brain signals? Security concerns. Like any connected tech, BCIs could be vulnerable to cyber attacks. Imagine someone hijacking your neural interface. This isn't just a plot from a movie anymore. Invasiveness and risk. While some BCIs are non-invasive, the most powerful ones still require surgery. That brings medical risks, costs, and regulatory concerns. Accuracy and limitations. Current systems aren't flawless. Non-invasive devices often have low resolution and slower response times. Plus, training the system to understand your brain takes time and patience. The global neurotech industry is booming, with investments exceeding $30 billion. Companies like Apple, Meta, and Nvidia are exploring brainwave wearables for everyday users. Researchers envision a future where neural interfaces are as common as smartphones. However, many experts argue that we need legal frameworks to protect what's now being called cognitive liberty, the right to think freely without surveillance or interference. This includes setting ethical boundaries around how brain data is used, stored, and shared. Let's fast forward a few years. You might walk into your house, think, lights on, and your smart home responds. You could browse Netflix with a thought or scroll through emails in augmented reality glasses without lifting a finger. Even education might change. Students could learn languages or code with brain-driven interfaces offering instant feedback. It sounds futuristic, but these concepts are already being tested in labs and startups around the world. Mind control tech isn't just possible, it's happening. As brainwave interfaces become more accurate, portable, and affordable, they could transform the way we live, work, and communicate. But like all powerful tools, they come with serious ethical and security questions. So, would you trust your thoughts to control your devices? Or does this kind of technology feel a bit too close for comfort? Let us know in the comments. Don't forget to like this video, subscribe to TechNow Explained, and ring that bell for more deep dives into the tech shaping tomorrow. Thanks for watching, and see you in the next one.